Question 4, we have been given a sample of bivariate data where both x and y are numerical, and we've been asked to work out by hand the covariance, and then for part B to work out the correlation, and part C to comment on the direction and strength of the relationship. Now, we've got 5 pairs of data here, and certainly when you're going to work through one of these small data set examples to calculate covariance and correlation, it is really useful to put the values into a table so that we can break down the covariance formula into its parts, and the table is a really good way to organise the different components of the calculation. Now, what we need to do is we're going to need to get each x and subtract the mean of the x's, and we're going to have to get each y and subtract the mean of the y. So we're looking for the x deviations and the y deviations, and then once we have those two, we're going to multiply them together, and that's what we'll do in that third column. Now, that tells us that we need to in fact have the mean of the x's, our x bar, and the mean of the y's, the y bar, before we start. Now, we've already looked at working out means previously. We just need to add up the numbers and then divide by how many we've got. Now, we've got 5 x values, 8, 16, 18, 21 and 22. If you add those all together and then divide by 5, you find that the mean of the x's is 17. Now, we have to do the same for the y's, so we need to get the mean of the y's, so y bar, and here we've got 30, 26, 23, 20 and 11, so add those together, divide by 5, and our mean of the y's is 22. So once we've got those two values, we're ready to start on our table. Now, it doesn't really matter if you work row by row or column by column, as long as everything gets filled in so that we can then complete the calculation. Now, just to start off, if we have a look at our first row and we do the x deviation, we've got an x value of 8, and so we need to do 8 minus 17, and that of course gives us -9. I'm going to work down through the rows. Our next one would be 16 minus 17, which is -1. Next we'd have 18 minus 17, which is +1. 21 minus 17 gives us 4. We've then got 22 minus 17, which is 5. So they're the x deviations. We've got -9, -1, +1, +4, +5. We do exactly the same for the y. So our first y is 30. This time we have to minus the mean of the y's, which is 22. That leaves us with 8. We've then got 26 minus 22, which gives us 4. We've got 23 minus 22, which gives us 1. We've got 20 minus 22, which gives us -2. And lastly, 11 minus 22, which gives us -11. Now we can go through and multiply the x deviation by the y deviation. So for our first row, that would be -9 times 8, which is -72. For the next row, we're going to have -1 times 4, which is -4. Then we've got 1 times 1, which is just 1. 4 times -2 gives us -8, and 5 times -11, which is -55. Okay, so there are all those calculations complete. I've just written down the full workings so that we can see exactly what's happening. Normally you just sort of work these out and write down the answers in the column, but you know, if you haven't done this type of calculation before, it might be nice to do a few sort of in full just to make sure you're comfortable with the technique. Now, our formula for correlation says that we have to get all of those x deviations multiplied by the y deviations and add them up and then divide by n minus 1, where n is the number of pairs. So if I add up all those values in the last column, I get negative 138. So I can put that bit into my formula, and then I have to divide by n minus 1, 5 pairs of data, so I'm going to be dividing by 4, and that gives me negative 34.5 as my covariance. So at this stage I can tell you that it is a negative relationship, but of course I can't comment on the strength until I work out the standard deviation, so that I can then turn it into a correlation value. So what we'll do is we'll just start onto another slide. Now, we've already worked out our covariance. We've got negative 34.5. To get correlation R, we need to use the covariance and divide that by the standard deviation of the x's. Just make that a bit neater. It's hard to write small on the iPad. Multiplied by the standard deviation of the y's. So to complete the correlation calculation, we already know that the covariance is 34.5 negative. I've got to get those two standard deviation figures. So I've actually got to work out the standard deviation of just the x's, and then the standard deviation of just the y's. Now, we've already had a look in question 1 at going through that process by hand. We'd work out the variance of the x's and then take the square root. We'd then work out the variance of the y's and take the square root. And if we go through that process and work out firstly the standard deviation of the x's, round it to 2 decimal places, it's 5.57. And if we do that for the y's, we end up with 7.18, rounded to 2 decimal places. So if you've got those values, you can of course substitute them in. We just divide our covariance by the standard deviation of the x's multiplied by the standard deviation of the y's. Put all of that into your calculator, and we end up with negative 0.86. So what can we say? Well, certainly we've still got the same direction as we had for our covariance, which we would expect. But we can now say not only that, so we'll say therefore we have a negative relationship, and in terms of the strength, it is strong. We've got a negative value that's close to negative 1. Negative 0.86 is definitely a strong relationship. So we have a negative strong relationship between x and y.